We're standing right on the edge of a new industrial revolution. But this one isn't powered by steam, it's powered by the incredible fusion of artificial intelligence and robotics. And believe me, this isn't just about making factories a little bit faster, it's about completely rewiring the way our world gets built. At its heart, this is about so much more than just efficiency. It's literally redefining the relationship between us, humans, and the machines we create. We're talking about a massive paradigm shift where machines go from just following simple commands to actually learning, adapting, and acting all on their own. So, Section 1, the new industrial revolution. To kick things off, let's take this huge, kind of abstract idea and ground it in a real world example that you can actually picture happening right now. Okay, so picture this, a drone equipped with AI powered vision, flying over miles of pipeline or scanning the surface of a massive bridge. Now, it's not just taking pretty pictures. No, it's actively analyzing those images in real time, spotting tiny stress fractures or corrosion spots that would be completely invisible to the human eye. It's a huge leap forward in both precision and, of course, safety. So how on earth is that even possible? Well, in Section 2, inside the AI engine, we're going to pull back the curtain and look at the core technologies that actually give these machines their intelligence. Industrial AI learns in a couple of really key ways. On one side, you've got supervised learning. The best way to think about this is like studying for a test with an answer key. You show the AI thousands of labeled pictures of, say, a defective part until it just gets it and can spot one on its own. But then you've got reinforcement learning, which is much more like learning through trial and error, and this one is absolutely crucial for robotics. Let's dig into that reinforcement learning idea for a second. This is exactly how a robot learns to get around a super complex factory floor. It tries something, and if it's a good move, it gets a reward. If it's a bad one, it gets a penalty. Now, after millions and millions of these little trials, it figures out the absolute best strategy, not because a human programmed it, but because it discovered it all by itself. And the brain that's doing all this learning? Well, that's something called a deep neural network. It's a really complex algorithm, kind of modeled on our own brains, that sifts through just massive amounts of data from sensors to find patterns and make decisions. This is the real engine behind modern AI. And these neural networks can be super specialized. So you can think of CNNs as the AI's eyes. They're experts at processing images, like spotting a microscopic defect on an assembly line. RNNs, on the other hand, they're the masters of time. They analyze sequences of data to predict when a machine might fail, before it actually does. But here's the thing. An AI is only as smart as the information it gets. And in a chaotic place like a factory, one sensor is just never going to be enough. That's exactly where sensor fusion comes in. It's the art of blending information from all these different sources to create one single crystal clear picture of what's going on. So for example, you can take the visual data from a camera, combine it with distance data from a LiDAR sensor, and then add in tactile feedback from a gripper. The AI fuses all these inputs together into one super accurate perception of its environment. You're basically giving the robot a kind of super sense. Now, in a factory, a single millisecond can be the difference between a perfect product and a very expensive mistake. You just don't have time to send data to some remote cloud server and wait for a response. That's why all this processing happens right there on the machine itself. This is called Edge AI, and it's what makes that real-time, split-second decision-making possible. All right, so now that we kind of get how the tech works, let's see it in action. In Section 3, Robots at Work, we're going to look at the incredible impact these intelligent systems are already having out there in the real world. Just think about this number for a second. A more than 50% reduction in the time it takes to fulfill an order. I mean, that's not just a small improvement, that's a staggering leap in efficiency. So how do you even achieve that? Well, in a traditional warehouse, you have people walking up and down fixed aisles. But in an AI-powered warehouse like the ones Amazon uses, you have fleets of autonomous mobile robots, or AMRs, that dynamically figure out the absolute best path to bring the shelves directly to the workers. It completely flips the whole workflow on its head. And this impact is spreading, it's going far and wide. In automotive giants like BMW and Toyota, AI-driven robots are doing high-precision welding and painting. In logistics, you've got automated guided vehicles that are the new workhorses. And like we talked about, in infrastructure, AI drones are becoming absolutely essential for maintenance. But listen, it's not all about replacing people. A whole new kind of partnership is emerging with what are called cobots, or collaborative robots. These machines are designed from the ground up with advanced sensors to work safely right next to people, helping out with the repetitive or physically tough parts of a job. They augment our skills, they don't just replace them. So, where is all of this incredible technology taking us? In our final section, The Factory of Tomorrow, let's explore some of the truly futuristic applications that are just over the horizon. One of the most powerful ideas for the future is the digital twin. Here's how it works. First, you build a perfect virtual model of a real-world machine. Then you feed it live data from sensors that are on the actual physical machine. This lets you run all kinds of simulations, test new ideas, and even predict failures in the virtual world before they can ever happen in the real one. It is a total game changer for optimization. And if we look even further ahead, we find swarm robotics. This whole idea is inspired by things like ant colonies, and it involves large groups of simple little robots that coordinate with each other using decentralized AI. I mean, just imagine a swarm of tiny drones mapping a disaster zone in minutes, or working together to build a structure, all without any single central controller telling them what to do. And what this all points to is one really clear vision for the next decade. We're talking about factories that can fully adapt to changing demands in real time, supply chains that optimize themselves, and robotic systems that are just continuously learning and getting better on their own. But of course, all this incredible progress also brings up some profound new questions. As these machines become more and more autonomous, making their own decisions based on what they've learned, it really forces us to ask, when something inevitably goes wrong, who's responsible? That's a huge challenge we're all going to have to figure out in this new industrial age.